is our second video about mean value theorems, and in this video we are going to discuss about Lagrange's mean value theorem. Now, statement of the Lagrange's mean value theorem goes like this. Lagrange's mean value theorem. The first two statements of the Rolle's theorems are applicable here also. So if fx is defined, it's a real valued function defined in such a way that fx is continuous on close interval ab. Number 2, fx is differentiable in open interval AB. And number 3, no third condition, fa equal to fb, this condition is omitted here. Then there exists a number c between a and b such that f dash c is fb minus fa over b minus a. Now we'll understand significance of these things. So first 2 points which you have seen, if you have seen our previous video, then we have discussed the continuity and the differentiability, what do they mean in that particular domains. Here we have to say condition, like the graph is continuous everywhere. So this is my graph. I take a graph like this. This is point A, this is point B. So this is fx graph. So at this point we have coordinate fa, and at this point we have fb. Okay, because this is my fx and this is my x. So function is continuous because there is no break in the graph of the function. It's differentiable, means at each and every points within a and b possible tangent is safe. Then there exists a number c between this where the tangent is possible. Now if you just try to connect them and find the tangent, so you know that tangent m is called as difference of ordinate, that is fb minus fa. So fb minus fa over b minus a. So fb minus fa over b minus a, this is nothing but the tangent. Even if those who have studied the coordinate geometry, they can understand it, that m is fb minus fa. So it means at each and every point a slope is possible, right? There is no denying this because you see same thing. Then there exists a number c between a and b such that f dash c. So it means this is, if you say this is my c, then there is a possibility of finding a tangent which will be parallel to the chord. This is, so if I say this point A, we say this line is the chord, and there is a possibility that between these two you can find a tangent which will be parallel to this. If the function goes in other way, then also this theorem always holds true. Now I hope this is very simple theorem, everyone can understand it easily. And now I'll take another example just to solve this theorem. Okay, so now I have taken another question which goes like this. If fx equal to x 1 minus log x and a is greater than 0 and less than b, then show that there exists at least one c, this is c, belonging to ab, open interval ab, such that a minus b log c equal to b 1 minus log b minus a 1 minus log a. First condition, we have to check whether the function is continuous or not. So if you see this 1 is a constant function, this is continuous everywhere, it's a constant function. Log x is a continuous function everywhere on the whole real line. Now 1 minus log x means the difference of two continuous function is also a continuous function. So 1 minus log x is continuous. Now x is a polynomial function and that is also continuous. Now product of two continuous function is also continuous, means overall the x 1 minus log x is continuous everywhere. So the first condition is there. Now same reason these functions are differentiable also. So second condition also, because log function is differentiable everywhere, 1 is differentiable and the x is also differentiable. So fx is differentiable. I can find f dash x directly using this product rule, x into this. So 1 into 0 minus 1 by x plus x into, I'm just doing everything. X should remain constant, x is constant, differentiation of this 0 minus 1 by x plus now x differentiation, that is 1, and differentiation of this should remain unchanged, 1 minus log x. So if you simplify, you find it as minus 1 plus 1 minus log x, f dash x. Now Lagrange's theorem says that fb minus fa. Now first we have to find fb minus fa. fb minus fa. So here you find b 1 minus log a minus a 1 minus log b 1 minus log b, a 1 minus log a, and f dash c. If I put the value of c here, so f dash c is minus 1 and plus 1 cancel, so you get only minus log c. So f dash c should be fb minus fa over b minus a. Now f dash c is minus log c. So minus log c is fb minus fa, means this whole thing. I can write, because here you see that it's very much same like this. So b 1 minus log b minus a 1 minus log a upon b minus a. Now I cross multiply. So what I get, minus b minus a log c is b 1 minus log b minus a 1 minus log a. Now there is, it's almost same, but only difference is this is a minus b and we have b minus a, but we have a negative sign. So if you introduce this negative sign in between b minus a, it will become a minus b. So this becomes a minus b log c is b 1 minus log b minus a 1 minus log a, and this is what we have to prove, and here we have proven that. Using the Lagrange's theorem, this relations can be proved. So this is the beauty of the Lagrange's mean value theorem, and this is all about the mean value theorem in the standard 12 of the Indian boards or in the international board. And in the next video we'll start integration. Thank you very much. Just subscribe to our channel.